Okay, guys, this is your video recording of me doing the rest of the review, and you can use this to help you answer, there's the bell, get any questions answered that you might have, while you're working on the review if you get stuck. Okay, so we did the first page. This is the first page. We went through all these vocab terms. This will be helpful for you on the test. Okay, and then I told you to cross off 20 through 29. So we're starting at 30. Okay, so for 30 says using any letters you want, give an example of a monohybrid cross. So mono refers to one. Hybrid means heterozygote. Okay, so I'm going to use capital M and little m. So a monohybrid cross means two heterozygotes crossing. And the expected phenotypic ratio from this monohybrid cross is going to be 3:1. And you might be saying to yourself, how did you know that? Well, if you were to look at a Punnett square of this monohybrid cross, capital M, little m, capital M, little m, you're going to see that 3 of the 4 are going to show the dominant trait, and 1 of the 4 is going to show the recessive trait. So when you do your phenotypic ratio, the first letter is always dominant. Or sorry, the first number is always dominant. The second one's always recessive. Okay? Using any letters you want, give an example of a dihybrid cross. So now this is 2 traits. Di meaning 2. Hybrid meaning heterozygotes. So that means two traits, both heterozygotes. So if I go capital A, capital B, little b, if it's a dihybrid, that means both are double heterozygotes. Now the expected phenotypic ratio from this dihybrid cross, this is going to be a 9 to 3 to 3 to 1. And that's just something you got to memorize for the test, because that will be on the test. A dihybrid cross results in a 9 to 3 to 3 to 1 ratio. Okay? All right, so if we look at then 32. Guinea pigs, rough coat, dominant to smooth coat, capital R versus little r. Male guinea pig, homozygous dominant. So that means both capital. Cross with a female who's heterozygote. Capital little for female. They want to know phenotype, genotype, the Punnett square, and then the phenotypic ratio, and then a probability. So let's start with the phenotype. Okay, the phenotype of the male is going to be rough because it has at least one copy of the dominant letter. The phenotype for the female is going to be rough because it has at least one copy of the dominant letter, the dominant allele. So they're both rough coat. The cross looks like this. So the expected phenotypic ratio, all of them are going to show the dominant trait because they all have one copy of the dominant allele. So it's going to be 4 to 0. So 4 dominant, 0 recessive. What's the probability that the offspring will have at least one dominant allele in their genotype? 100%. And you can look at the Punnett square to show this. Okay. All right, here's the toughest one on here. The double trait cross. So you have in ducks, short bill, capital B, dominant to long bill, lowercase b. White feathers, capital F, dominant to yellow feathers, little f. A duck with a long bill and yellow feathers is crossed with a duck that is heterozygous for both traits. Oh, okay. Here we go. Max and Paulina and Charlie and Luke, if you guys are watching this one, I think I did it a little bit different for you guys. So I got a duck with a long bill. So that means, oops. little b, and yellow feathers, which is little f, is crossed with a duck that is heterozygote for both traits. Capital B, capital F, little f. Okay, what are the phenotypes of both ducks? Well, we know that one is long bill, yellow feathers. That's the all recessive one. The double heterozygote is going to show both dominant traits. So it's going to be short and white. Okay, completing the Punnett square. For your homozygous recessive in both cases, each gamete that's produced is going to be little b, little f. And then the heterozygote, we can do the FOIL method. So that's first, capital B, capital F, outer, capital lowercase, inner, lowercase capital, and then last, which is little, lowercase, lowercase. Okay? So now filling this in becomes a little bit easier because you have one gamete that's all the same, which is your top gamete. So you're going to notice that, well, I guess if we go down, or no, actually, as you go across, it's going to be the same. So if I just fill out one column, rather, this is going to be capital little. This is going to be little, capital, little. And this is going to be all little. I can actually copy this, paste, and I'll have everything filled in, and everything matches and makes sense because the top row of gametes are all the same. All right, now the expected phenotypic ratio from this cross, I'm going to have 4 different types of phenotypes, and they're all equally represented. I'm going to have one type of phenotype that shows both dominant traits, and that's this whole row. So there's 4 of them. I'm going to have one phenotype where I'm just dominant for bill type and recessive for feathers. So that's this row. I'm going to have one that is recessive for bill type and dominant for feathers. So that's this row. And then I'm going to have one that's recessive across the board. So that's this row. So my phenotypic ratio is 4 to 4 to 4 to 4, or you could say 1 to 1 to 1 to 1. Probability that you're going to have long bills. Now remember, long bills is lowercase b. So that means that I'm showing the recessive b for both alleles. So little b. And if you look at it, all 8 of these are little b. So the probability is 50%, or 8 out of 16, which is really 1/2. Probability that the offspring would be heterozygous for both traits. The only row that's heterozygotes are that first row. So that's going to be a 4 out of 16, or 1/4. Okay. Here you have, the last one is going to be your pedigree. So free earlobes, capital E, attached earlobes, little e, just like the notes we did. Just some questions. How many people are shown in generation 3? So generation 3, we got 5. How many children did the original couple have? This is the original couple. They had 1, 2, 3, 4, 5, 6. What is the sex of the oldest child? Oldest child from generation 2-1, generation 2-2. So this is the oldest child from those identified individuals. That would be male, since it is a square. And then here's the tricky questions. What is the genotype of Roman numeral 2-4? So they're wanting to know the genotype of this person, 3-3, this person, and 2-5, this person. So we can do the easy one. This one right here, 3-3 is going to be both recessive. So little e, little e. 2-4 and 2-5, if you look at their parents, it's little e, and the mom from the original has to be a heterozygote. And the reason why she has to be a heterozygote is because some of her offspring are showing the recessive trait. So that means if you were to do a Punnett square, the only options are you're going to have a recessive EE or a heterozygote, capital E, little e. Okay? So that means capital E, little e, capital E, little e is the only option for these two based off of that Punnett square. Okay, I hope this